Assalamu alaikum guys, welcome. This is Shafat Khan on your screen and we are back with the AS chemistry crash course, lecture 20, in which we are going to talk about the types of covalent bonding or the types of covalent bonds. Two types which we have to study in this lecture are known as the sigma bond, type number 1, and the pi bond, which is the type number 2. Alright, sigma bonds and pi bonds, you must know the difference between them. You must know the difference in their strengths, you must know the difference in their composition, you must know how they are formed. Okay, so these are the three things that we have to cover in this lecture. So let's begin now. Alright guys, so first of all, before we move on to the sigma bonds and the pi bonds, you must know the orbitals, the shapes of the different orbitals which you've studied so far. Remember what was the definition of an orbital? Orbital is basically the region of space in which the probability of finding an electron is maximum. Okay, and the four types of orbitals basically we've studied in our course are SPDF, right? But in AS you are not supposed to study the D and the F structure. Basically the S and the P shapes are enough, more than enough. The D's shape will come in A2, alright, and F shapes are not in the syllabus because that's a bit complicated. Now coming to the S orbital first. S orbital, as the name S suggests, from S, just remember it's shaped to be spherical. Okay, spherical. So S orbital is spherical in shape, and this is how you can draw a sphere in 2 dimensions, basically a circle. But this is what you are supposed to draw if you are asked to draw out the shape of an S orbital. So a sphere, a circle. Then P orbital. P orbital looks like a dumbbell. Okay, dumbbell shaped orbitals. Okay, this is how it looks like. Okay, and this is how it looks like. So it can either be vertical or horizontal. This is the shape of P orbitals. Okay, both are P orbitals basically, but the only difference is that this is upright and this is horizontal, but doesn't matter. If you're asked to draw the shape, you can draw any one of them. And this is how the d orbital looks like. Well, this is not the only d orbital out there because there are 5 different types of d orbitals. So of course all of them would have different shapes. So yeah, so for now you just think of this as being one shape of d orbital, but you don't need to remember the shapes of d orbitals, okay, for your AS especially. Now coming to the sigma and the pi bonds, basically how they are actually made. Remember guys, whenever you have to form a covalent bond, first of all, covalent bond is formed by the sharing of electrons. How are the electrons shared? Basically in O levels you used to study that electrons are just shared, right? They are sharing. How is this sharing actually done? This sharing is done by overlapping the orbitals which are there in different atoms. Okay, for example, if the s orbital, if there are certain electrons in a certain atom, for instance you have got chlorine. Okay, chlorine which has a proton number of 17, right? Chlorine has 7 outermost electrons, right? By 7 I mean and if you represent the number of electrons in terms of orbitals, the outermost electrons are present in the p orbital, right? The p orbital has 5 electrons. Now these are the 3 p orbitals present in chlorine, right? And chlorine has, the outermost shell has how many electrons? It has actually not 5, it has 7 electrons, right? 7 electrons, but the 2 of them are present in the s orbital, right? And the remaining 5 are present in the p orbital. So 2 are here and these are the remainder of the electrons. Now if you look at the last orbital, it has an unpaired electron, right? Now this unpaired electron can be paired by forming a covalent bond. Okay, for instance, this chlorine atom over here, if it has to form a covalent bond with hydrogen, hydrogen only has a single electron, only one electron present in its orbital, and the only orbital that is present in hydrogen is the s orbital, right? And these are the p orbitals and the s orbitals of the chlorine. Now there is one electron in here in hydrogen, and there is one electron in the p of chlorine. So what we can do is, while forming a covalent bond, these 2 electrons, they can combine with one another. Basically the 2 orbitals can mix together, and after the mixing a paired orbital will be formed, meaning 2 electrons will be present in that orbital which will be shared. Okay, this is the basic concept of covalent bonding, how covalent bonds are formed, but you don't actually need to know this detail, okay, in your AS syllabus. That's the fun part. What you actually need to know is how the orbitals overlap with one another, forming a sigma bond or a pi bond. First of all, how is a sigma bond made? Sigma bond is made when an s orbital of one atom, it overlaps with the s orbital of another atom. Okay, simple as that. So this is the form of bonding, a form of overlap that you should expect. SS orbital, and this is the overlap in between them. Okay, this is how you show the SS orbital. This is one example of sigma bond. Think of it, the sigma bond, as being a single covalent bond. Okay, every single covalent bond which is out there is a sigma bond. Just learn this fact that every single covalent bond is a sigma bond. Okay, this is one fact that I would want you guys to note, that every single covalent bond is a sigma bond, whereas the double covalent bond is going to be a pi bond. It will have a pi bond as well as a sigma bond, but we'll come to that. First of all, SS overlap will result in a sigma bond. SP overlap will also result in a sigma bond. Okay, if there is an s orbital of one element and a p orbital of another element. So as far as the s is concerned, the s orbital, it will always form a sigma bond. Okay, SSSP. Okay, S for s orbital and S for sigma. S for sigma. So remember the S and S for both of them. So s orbital will form a sigma bond. So whenever an s orbital overlaps with itself, with an s orbital, it has to form a sigma bond. Or when it overlaps with a p orbital, it forms a sigma bond. Now coming to the pp overlap. The only overlap which is left, of course, because the d orbital is not in the syllabus. So now, pp overlap. How will the p overlap? First of all, if one p orbital is horizontal, right, and the other is also horizontal, and they overlap head-on, meaning the heads of both the orbitals, they overlap with one another horizontally, then the type of bond which is formed is going to be a sigma bond. Okay, so this is one fact that I would want you guys to remember, that pp head-on overlap will result in a sigma bond. Okay, pp head-on overlap will result in a sigma bond. By head-on, I mean the horizontal overlap, and head-on is the key term over here. pp horizontal or head-on overlap will result in a sigma bond. Whereas a pp sideways overlap, if both the p orbitals are now shifted by 90 degrees and they are made perpendicular to their original location, original position, and now these vertical p orbitals, they overlap with one another, resulting in two regions of overlap. Okay, two regions of overlap. Then the type of bond which will be made is called a pi bond. Okay, so what is a pi bond? It is basically the sideways overlap between two p orbitals. What is a sigma bond? It is the head-on overlap between two p orbitals, or between two s orbitals, or between an s and a p orbital. Simple. So there are three ways to form a sigma bond, but one way of forming a pi bond. So this is what you need to remember. So let's summarize what we've learned so far over here. How is a sigma bond made? Sigma bond is made. Okay, how many bonds? What type of bonds are sigma bonds? All single covalent bonds are sigma bonds. Okay, for example, hydrogen single bond, sigma bond. HCl, hydrogen chlorine single bond, is a sigma bond, and so on. Okay, all the single covalent bonds. Methane over here, methane molecule, CH4, all the four bonds are single bonds, so they are all sigma bonds. And what sort of overlap is there? The hydrogen always will contain an s orbital, because hydrogen has only one electron. One electron means it's the only electron that it has. 1s1 is its electronic configuration. This means the electron which it has is in the s orbital. Whereas this carbon over here, it has a p orbital configuration, because if you look at its electronic structure, it has its proton number is 6. So what are the outermost? Let's write down the electronic configuration. It's going to be 1s2, 2s2, 2p, 2. Right? So this means there are 2s and 2p electrons. So two of them are going to be ss overlap, and the remaining two are going to be sp overlap. Okay, in this case, because it's the outermost electrons that overlap, right? That form the covalent bond from your basic previous knowledge. So over here, all the bonds are still sigma bonds. Okay, because they either are the sp overlapping bonds or the ss overlapping bonds. Now I was summarizing, right? So I said that all single covalent bonds are sigma bonds. Now you've got three types of orbitals, basically two major types that you'll study in your AS, either the s orbital or the p orbital. If the s overlaps with itself, from the s, remember that it's going to be a sigma bond. So if s either overlaps with itself, it's going to be a sigma bond, or s overlaps with the p, it's going to be a sigma bond. Finally, the pp overlap. So pp overlap can be of two types. If it collides head-on and there is only one region of overlap and there is a horizontal overlap between the p orbitals, then it's a sigma bond. And if there is a sideways overlap, meaning both the p orbitals are vertical and there are two regions of overlap, then it's a pi bond. Alright, so this is how, the difference between sigma bonds and the pi bonds. And by the way, which bonds are going to be stronger in nature, meaning which one will require a greater amount of energy to break them? It's the sigma bonds, okay? Remember that the sigma bonds are always going to be stronger than the pi bonds. Pi bonds individually. Okay, because pi bonds have two regions of electron density, sigma bond has only one region of electron density. One region of electron density means that the region of overlap is very compact and strong. Over here, the region of overlap has been dispersed in two different points and the overlap is not very strong. And plus, you've got the nuclei as well, so the nuclei might be repelling each other. But anyways, it's the overlap that contains the electrons, right? So, sigma bonds are stronger than the pi bonds in terms of strength. Now coming to the representation, the general representation of sigma and the pi bonds. Basically, as I told you, okay, this is a molecule of ethene. Ethene, you must have studied ethene. It is an alkene from in your O levels, organic chemistry, right? Ethene, C2H4, ethene. Now, C2H4 contains a carbon-carbon double bond, carbon-hydrogen single bond, and 4 of them, right? Now, this carbon-carbon, all the single bonds over here are sigma bonds. Okay, for now, just forget the pi bonds. All the single bonds, they are sigma bonds. And even in this double bond, the first single bond which was made is going to be the sigma bond, okay? Let me repeat. In the carbon-carbon double bond, the first bond which is made is the sigma bond and the next bond which is made is the pi bond. Okay? So this is important. So in this molecule, how many sigma and pi bonds can you see? So there are 5 sigma bonds and 1 pi bond. Okay, this is important because questions like these have been asked to identify the number of sigma and pi bonds in a particular molecule. This is a very basic example. Of course, they'll give you a more complex molecule on your syllabus, on your basically CAIs. Now, if this molecule has to be represented in terms of orbitals, so how will it be represented? So basically, this is how you will look at the molecule. The carbon-carbon, this sigma bond and pi bond, I have drawn it like this. The orbitals are shown half. Okay, the sigma bonds, the p bonds, which have to be overlapping head-on or horizontally, I have removed the other half of it. Okay, this half has been removed and only the overlapping halves have been shown over here for simplicity. Okay, because this is acceptable. Okay, you can do that. Then for the pi bond, you know that it's a vertical overlap, right? The p orbitals, they are vertical. So the p orbitals of this carbon, they are vertical and they are overlapping with one another. This is how you are going to show them. This is how a pi bond looks like, and you can see, you can appreciate the two regions of overlap. This is the first and this is the second region of overlap in the pi bonds. And in the sigma bonds, this is the only region of overlap. So this is how you are going to represent the pi bond and the sigma bond. And then the remaining sigma bonds, they are p and s overlap, meaning sp overlaps. The p orbital of carbon and the s orbital of hydrogen. So this is the first overlap, this is the second, this is the third, and finally this is the fourth one. So these are all sigma bonds. So 1, 2, 3, 4, and you've got this sigma bond, fifth, and then this is the pi bond you have. This is the representation that you have to draw out when you are asked to draw in terms of orbitals. Okay, but this isn't a very common question though. Not a very common question. And this same thing can also be represented using this notation. Okay, this carbon-carbon sigma bond, since we know it's a single covalent bond, can be represented by a single bond over here. I've drawn a single bond. So I have labeled it as sigma bond. Whereas this pi bond on top and at the bottom, it can be represented by 2 kidneys above and below. Okay, 2 beans. This is a region of electron density, a kidney-shaped electron density and a kidney-shaped electron density below that single covalent bond. So this carbon-carbon double bond basically can also be represented using this notation. Both of them are accepted. Both of them have been given in the marking scheme as well. Okay, so this sums up this sums up the discussion on sigma and pi bonds. Now guys, I want to ask you something. If you've got, let's say, a carbon-carbon single bond and you've got a carbon-carbon double bond, and you are asked to tell us which of the 2 bonds are the stronger bonds, Meaning, is the double bond the stronger bond or the single bond the stronger bond? So what's going to be the answer? Basically, in the single bond, you've got only sigma bond, whereas in the double bond, you've got a sigma bond as well as a pi bond. So in a double bond, you've actually got two bonds. So you have to break the pi bond and then the sigma bond. So the carbon-carbon double bond collectively is going to be stronger than the carbon-carbon single bond. Okay, but if you are asked to compare the strength of just this pi bond and the sigma bond, then of course the sigma bond is going to be stronger. Okay, if you are asked to compare the strengths of sigma and pi bond, then the sigma bond is stronger, just single sigma bond. But if you are asked to compare the strength of a single and a double bond, then the double bond is going to be stronger. Why? Because the double bond contains sigma and a pi bond. In case of this double bond, we've already done. Triple bond. In case of triple bond, how many sigma and pi bonds do we have? The first bond which is formed is always going to be the sigma bond. Okay, and no matter how many bonds are formed after that sigma bond or in between those two molecules, they are all going to be pi bonds. Okay, so we've got one sigma and two pi bonds in this case. Same goes to nitrogen. You've got the first sigma and two pi bonds. This sums up everything about sigma and pi bonds. Now in the next lecture we are going to talk about the bond energies and bond lengths of covalent bonds. Thank you.